we all know not to turn your thermostat down too low in the wintertime because it causes some problems with your pipes. Well, Matt Sellen, our wise guy, is here to explain all of the physics behind why pipes burst. Thanks for being here today.
Oh, that's always fun. You know, I was motivated by this because we have kind of a not very well insulated basement with a fridge in it, and so we keep drinks and things down there, and so it got extra cold in there. When it got cold outside, the basement got cold and the stuff in the fridge froze, and the soda bottle or can ended up looking like this. See how it's kind of bulged out at either end?
Right.
I thought, wow, that's really interesting. I think I'll do something on that. So what I did, I tried to do my own experiment, you know, just to repeat this once again. So I put in the freezer on purpose a Diet Coke and a Diet Beer, a Miller Lite, and I put them in plastic bags, you know, to keep the mess down. Well, the Diet Coke just blew up, and it blew out of the bag and all over the freezer, and the beer didn't do anything.
Really?
So, yes. Anyways.
So we don't know, just more carbonation
Well,
in here?
I think we have to do further experimentation on that. But anyways, it made me think about thermal expansion, and usually most things, that's right, most things sort of tend to get a little less voluminous. They shrink a little bit when they get cold. And that they get more dense. And so that's something we can actually relate to that, because when you're hot, you're kind of like, when you're cold, you're kind of like this. And so even you are a little bit smaller, and the way atoms do this in solids by vibrating a little bit less when they cool off, and so things just get a little bit smaller, not very much. But you can see this effect very easily. Here in this liquid nitrogen, I had been cooling this little metal hoop, which was exactly identical to this other metal hoop. But the difference now is that this one's a little smaller. You can see because this thing fits through that one and doesn't fit through that one. So this one shrank a little bit. It's very hard to see, but that's why when they build railways and things like that, they always leave little gaps between the rails because they're going to expand a little bit when they get hot. And also in bridges, you see these expansion cracks. Okay? Now, water is kind of like that, in that if you take water, which is warm, and you cool it off, it gets a little bit more dense. You cool it off, it gets a little bit more dense. And the reason density is interesting is because density determines how things will sink or float. Okay? So anyways, so when you get down to about 4 degrees C, which is 4 degrees above where water freezes, then something weird happens. It starts to get bigger again. It gets less dense. And ice itself is a lot more, or a lot less dense, I should say, than water is. So ice floats. So if, in fact, in this cup of water, what you'll see is that I just put a bunch of ice cubes in it, and if you zoom in on it, you see that the ice is floating on top. Not only that, some of it is sort of bulging up over the top. And these are like icebergs, in fact. When you see these enormous icebergs in National Geographic and whatnot, you're seeing just the top, which is just the top 8% or so of the ice. Everything else, more than 90%, is underneath the water surface. Okay? And in fact, if you take an ice cube and you drop it in some alcohol, which is what I have right here, it sinks like a rock because alcohol is less dense than ice is. It's just not the same as water. Okay, so the density determines what floats and what sinks. It also, though, is interesting because as water freezes, it gets bigger. Okay, and so that's what's going to burst your pipes, and that's what made these cans blow up and what made this thing big. And so what I'm going to do an experiment, and we're going to, when we come back on the second half, we'll see what the result of the experiment is. I'm going to pour some water into this tube, and I've glued, this is a PVC pipe, half-inch pipe, that I've glued the bottom cap on very tightly, and I'm just about to put the, there we go, put the water in there. I'm going to put the top cap on without glue, but I'm going to whack it in there so it's tight. I'm going to drop it in the liquid nitrogen, which is just going to freeze the water.
So we're going to come back in half an hour and see what happens?
You could do this in the freezer, but it would take longer than we have, and we'll come back and we'll see what happens. And the other thing I want the listeners to predict is, over here, where this ice is floating on top, by the time we get back, that ice will be mostly melted. And I want you to predict whether or not the water, which is now right at the lip of that glass, will have spilled out when the ice melted.
Interesting. All right. We'll be back with Matt's in 30 minutes. Get your predictions ready. We'll also be back with reading your emails about the Super Bowl predictions and your quiz answer. Stay with us. And right now we're going to check in with Jennifer Ketchmark with our Storm Tracker Weather on the 3.